Okay, so let's look at an applied problem. So we're driving all afternoon, and the distance we've traveled after so many hours is given by this function right here. And they don't tell us how long we're traveling, but they do tell us the restraint on the number of hours is between 0 and 5. So that means in total, we're going to travel for 5 hours. So again, this function f tells us the distance that we've traveled, or this person in the examples traveled, after so many hours. Okay, so for part A, they want to know how far we traveled after 3 hours. Well, that's nothing complicated. All we got to do is take that time and plug it into the function. So to find the distance after 3 hours, we just take t equals 3, plug it into the distance function, and we'll get our answer. And we can round our answer to 134. So after 3 hours, we've traveled approximately 134 miles. So now in part B, we're asked to find the instantaneous rate of change, her velocity, or her speed, or our speed, at this time, t equals 3 hours. So at the particular point in time as we're traveling, what is our speed? So how do we find that? Well, anytime you see instantaneous rate of change, that's your code word for derivative. Also velocity or speed, same thing, code word for derivative. So when they tell you to find the instantaneous rate of change, to find the speed, to find the velocity, that's telling you you need to find the derivative. So to answer part B, we want to find f prime evaluated at 3. We know we need to find f prime because they tell us to find the derivative, and we know we need to find f prime evaluated at 3 because they tell us at t equals 3 hours. Well, in order to find f prime of 3, we have to first find f prime of x, and then we can plug 3 in for x, or I should say f prime of t in this case. So first we need to find f prime of t, and then we can plug in 3 for t. Okay, so f prime of t is just the derivative of the function f. So it's the derivative with respect to t of all of this. Now we can use our most recent rule and just distribute this derivative operator over this addition and subtraction. Okay, and now we need to take the derivative of each of these individual pieces. Well, if we look at each piece, they're all going to be the power rule with a constant out front. So like the derivative of this first guy is just going to be 1.85 times 3, and then t to the power 3 minus 1, so t squared. Then the next guy would just be 18.17 times 2, and then t to the power 2 minus 1. And then the last guy, it's 82.15 times 1, and then t to the power 1 minus 1. So whenever you have just t to the first power, basically the t is going to go away, it's going to go to 1, and you're just going to be left with whatever the coefficient was. Okay, now we can just simplify each of these guys. So 1.85 times 3 is 5.55, so we have 5.55 t squared minus 36.34 times t, and then plus 82.15. Because again, with this last term here, we have t to the 1 minus 1 power, which equals 0, and anything to the 0 power, so t to the 0 power, is just going to equal 1. Okay, so this is our derivative function. This is our f prime of t. But for part B, what we really want is f prime of 3. So now we just need to plug 3 into our derivative function. And when we plug that into our calculator, we should get approximately 23.4. So that's the value of the derivative at time equal 3. And because this is a distance function, if you take the derivative, or find the instantaneous rate of change, then what you get is a speed. And we know this is true based on the units we have. So think about what should the units be of the derivative? Well, I've told you already it's speed, so then you should probably know this. Usually, since we have the distance function in miles and our times in hours, then our speed will be miles per hour. But if we didn't know that what we just found was a speed, then how would we know what the units were? Well, our Leibniz notation helps us because our Leibniz notation was dy over dx. So if you think about it, the numerator is going to have the units of y, and the denominator is going to have the units of x. So in this case, our units are miles over hours, or miles per hour. So if you remember in college algebra or intermediate algebra, you should have learned how to find the units of slope. This is the same exact thing. Because remember, our derivative is a slope. It's a slope of the tangent line. So finding the units of slope and finding the units of derivative work the same way. It's just going to be the unit of the y variable, or the unit of the value of the function, over the units of x. So the example we just did, we can look at it graphically. This red line is the distance function. And we found after 3 hours, the distance traveled was 134. So that's this point right here. And then we found the derivative at time equals 3 hours. And so that will be the slope of the tangent line that goes through this point.